All right, guys, I just wanted to go through the review with you guys. So you had the answers if you wanted to take a look back at them and check to see how you were doing or to help you out with the assessment, either one. Now, as I'm going through these, they might not be in the same order as your problems just because I think I randomized the orders when I assigned the assessment. So you might have to look through a little bit. If there's one that you had a question about in particular, it might not match up with what you have on your review. So this is the Chapter 19 review. And I'm going to go through those 14 problems. So first one, when charges interact, like charges attract and opposite charges repel. Now, hopefully this is a pretty easy one for us because we've been told for a long time that opposites attract, right? And like things repel, which is the exact opposite of what we've been told here. So we should get false. All right, when charges interact, opposites attract and likes repel, not likes attract and opposite repel. Number 2, which statement is true for an object that is neutral, electrically neutral? So this one starts to get at, right, what does it mean for an object to be electrically neutral? And for almost all objects, right, the reason that they are neutral is because of this second guy right here. It has the same amount of positive and negative charge, right? It becomes neutral because the positive charges cancel out with the negative charges and we're left with a 0 total charge. There are very few things that have 0 charge overall. Actually, there's nothing really that has 0 charge overall. Almost everything is a balance of positives and negative charges. So to say that it has 0 charge is not technically correct. And we definitely know why things are neutral. It's because they have a balance of positive and negative charges. So for an object that is neutral, it has the same amount of positive and negative charge, which is what's making it balance out to have a neutral charge. Number 3, 2 charges, 7 coulombs and 14 coulombs, are 1 meter apart. If the 14 coulomb charge pushes on the 7 coulomb charge with a force of 98 K newtons, that's just so I didn't have to multiply by that 8.99 times 10 to the 9th. It just makes it a little bit easier. So 98 K newtons, how much force does the 7 coulomb charge push on the 14 coulomb charge? Now, this one gets back to Newton's third law, right? And if we remember Newton's third law, every force has an equal and opposite reactive force. So, if the 14 coulomb charge is pushing on the 7 coulomb charge with a force of 98, then the 7 coulomb charge has to push on the 14 coulomb charge with a force of 98. Now, it'll be in a different direction, right, because it's got to be opposite. So it'll be in a different direction, but it'll be the same size. It'll still be 98 newtons, right? You might think that it might be less because it's a smaller charge, but it's a smaller charge that has more to push on, whereas a bigger charge that has less to push on. So those charges balance out, right? The 7 coulomb charge doesn't have as much charge to push with, but the 14 coulomb charge has more to push on, right? And the 14 coulomb charge has a lot more to push with, but the 7 coulomb charge has a lot less to push on. So those balance out, and we end up with the same amount of force regardless, right? So if something pushes on one thing with a force, then the other thing pushes back with the same amount of force, right? It always balances out. System consists of electrons and protons. It contains 5 protons and a total charge of -2. How many electrons are in the system? So if our total charge is -2, right? What does that mean? Negative 2e. That means that there are an overabundance of negative charges, right? We have negative 2, or I guess I should just say 2. We have 2 more negatives than positives, right? If our total charge is negative 2e, that means we have 2 more negatives than we have positives. So if we have 5 protons, we have to have 5 electrons to balance that out, and then we need another 2 electrons to make up for that extra charge. So to get from 5 to negative 2, right, from positive 5 to negative 2, we need 7 electrons, right? 5 of those will go to balancing out the 5 protons, and then the extra 2 will be what contributes to that extra negative 2e of charge. So the answer here is 7 electrons. All right, we have 2 more electrons than we do protons. If we have 5 protons, we have to have 7 electrons. All right, same kind of question. System consists of electrons and protons, contains 120 electrons, and a total charge of 130, positive 130e. How many protons are there? So if we're positive, that means we have extra protons, right? We have more protons than we have electrons. And we have 130 more of them than we have electrons. So if we have 120 electrons and we have to have 130 more protons, well, 120 plus 130 will give us 250 protons, right? We've got 250 protons because we have the 120 to balance out the electrons, and then we have to add on another 130 to get to the extra 130 coulombs worth of charge. When an object becomes negatively charged, does its mass increase, decrease, or stay the same? So when an object becomes negatively charged, right, in order to become negative, an object needs to gain electrons, right? Electrons are the negative charge. So if we want to become negative, we have to gain electrons. And if we're gaining electrons, what do we think happens to the mass? Well, if you're gaining things, the mass has to go up. So when an object becomes negative, the mass has to increase. Now, the opposite of that is true for things that become positive, right? If in order to become positive, right, things have to lose electrons. And if we're losing electrons, what's going to happen to the mass? The mass is going to go down. All right, so when things become negative, they increase in mass. When things become positive, they decrease in mass. We've kind of had a question like this too already. System contains 72 electrons and 45 protons. What is the total charge? So we get negative 72 from the electrons. We get positive 45 from the protons. That leaves us with negative 27e for the total charge, right? Electrons contribute to negative charge, protons contribute to positive charge. We add those together to get the total charge, and our total charge becomes negative 27e. Easy one. Using the table, state which object will become positively charged and which object will become negatively charged when we rub PVC and cotton together. Now, I don't have the table here because I didn't feel like drawing it out, but if we look at the table, we see that cotton is above PVC on the table, right? If we look at the table, it's going up there. Cotton has a negative, one negative, and PVC has like 5 negatives or something like that. 1, 2, 3, 4, 5. So if we look at that, right, whatever one is higher on the table will become positive, whichever one's lower on the table will become negative. So in this case, because cotton is higher on the table, cotton will become positive, and PVC will become negative. Right? You just look at the table, whichever one's higher up on the table will become positive, whichever one's lower down on the table will become negative. These negatives and positives that are next to them don't really matter, right? All we're looking at is which one's higher on the table, which one's lower on the table. So 9 here, I have the same kind of question, right? Using the table, which one becomes positive, which one becomes negative. We have rabbit fur up at the top of the table with like 5 pluses or 6 pluses or whatever it is, plus, 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 plus. And then we have Teflon down at the other end of the table with minus, 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 right? Again, the plus and negatives don't really matter a whole lot. It just matters which one's higher on the table and which one's lower on the table. So because rabbit fur is higher on the table, rabbit fur is going to become positive, and Teflon is going to become negative. All right, look at the table. Whichever one's higher up becomes positive, whichever one's lower down becomes negative. Match the particle with its charge. Hopefully this one was pretty easy for you guys. Protons are positive, neutrons have no charge or a balanced charge, and electrons are negative. Neutrons are like the one thing that we can say has no charge. Any other thing is a balance of positive and negatives. Neutrons are the one thing that actually have no charge at all. So protons positive, neutrons no charge, electrons are negative. Rank the system in order of increasing size of the electric force. So to find the electric force, right, what we want to do is multiply the first two and then divide by the square of the second. So 1 times 2 divided by 1 squared. That will give me 2, right? And negatives don't matter, right? In these types of problems where we're just ranking the size of the force, we don't need to worry about negatives. And if you look at the equation, for Coulomb's law, it's absolute values signs anyway. It's F equals K times the absolute value of Q1 times the absolute value of Q2 divided by R squared. So what we want to do here is this column is Q1, this column is Q2, this one is R. So we want to take column 1 times column 2 divided by column 3 squared. So 2 times 4 divided by 3 squared. That'll give me 8/9. 5 times 5 divided by 5 squared. 25 divided by 25 is 1. 16 times 3 divided by 4 squared. 4 squared is 16, so we can cancel those 16s and we get 3. So for our columns here, we get 2, 8/9, 1, and 3. Then we want to rank those in increasing order, right, from smallest to largest. So 8/9 is the smallest, that would be B, then 1, which is C, then 2, which is A, and then 3, which is D. So we would rank them like that, right? So we want to multiply first and second, divide by the third squared, because we're using Coulomb's law. Now, we don't have to worry about the K because we're just comparing things, so it doesn't matter that, right, they would all each be multiplied by K. So if they're all multiplied by K, it doesn't really matter in our ranking of them. When an object is positively charged, right? So if we have a positively charged object, what do we know about it, right? It has more protons than electrons. Perfect. If an object is going to be positively charged, it has to have more protons than electrons because protons contribute to positive charge, electrons contribute to negative charge, right? If it had more electrons than protons, then it would be negatively charged, not positively charged, which makes no sense. It has more protons than neutrons. Now, this could be true, but it could also not be true, right? The neutrons don't play any effect on charge because they're neutral, right? They don't have a charge, so we don't need to worry about it. And then equal amount of protons and neutrons, we should know already from one of our previous questions, that makes something that has 0 charge. So we don't want that as an answer. So the only possible answer is that it has more protons than electrons. Almost finished. What is the size of the charge on an electron? This one you just have to memorize. It is 1.6 times 10 to the negative 19th coulombs. Also true for protons. Protons and electrons are the same, right? They have the same size charge. Do they have the same sign charge? No, because protons are positive and electrons are negative, but they have the same size charge, right? They're both 1.6 times 10 to the negative 19th coulombs in size. Match the particle with its mass. Electrons, 9.11 times 10 to the negative 31st. Protons, 1.673 times 10 to the negative 27th. And neutrons are the biggest, 1.675 times 10 to the negative 27th. All right, again, something you just have to memorize, the size of the electron, proton, and neutron. And last but not least, state whether the following are possible charges because of charge quantization. So when we're checking whether things are possible charges, what we really want to do is look at the first number and see, is it divisible or does it divide into by 1.6, right? Because 1.6 times 10 to the negative 19th, that's the charge of electrons and protons. So in order for these to be possible charges, they have to be divisible by 1.6. So if we try 3.2 divided by 1.6, we get 2, so this is possible. That would be like 2 electrons or 2 protons or whatever. We check this one, 4.8, we should get 3, right? 4.8 divided by 1.6 is 3, so that is possible. That would be like 3 electrons or 3 protons. We check 5.2, and 5.2 does not go in evenly, right? It would be like 1.5 times or 1.25 times or something like that. So this is not possible, right? It would be like 3 point something, 2 or something like that, right? Electrons, which is not possible. We can't have parts of electrons. That's not okay. So the 5.2 is not possible because it's not divisible by 1.6. And then 6.4, we check that. That one is possible. 1.6 goes into that 4 times, so that would be like 4 electrons or 4 protons. So that one is possible. So we just got to check, is the first number divisible by 1.6? And if it is, then it's possible. If it's not, then it's not possible. All right, that's 15. I think there were only 14 questions on the review, so I must have added an extra one in there someplace. So bonus, why not? All right, that's it for this one. If you guys have any questions, remember I have office hours every day, 3 to 4 o'clock. You can come drop by. I'll be there. All right.